So atoms, we have some electrostatic forces to join them, right? That is what we call a bond. So you have negative particles and positive particles. Now you know what are negative and positive. So they connected using a bond. So there are various ways in such electrostatic force can be produced between atoms in solids, right? According to the nature of force of attraction, bonds are classified as primary bonds and again secondary bonds. So there are two categories of bonds. First one is primary and second is secondary. Primary bonds are interatomic bonds. So they are stable and relatively strong bonds. We call metallic, ionic and covalent. Right? They are forming in between atoms. That is the primary bonds, and secondary bonds are intermolecular bonds. So primary are interatomic and secondary are intermolecular. Right? So we'll discuss this one. They are relatively weak. They occur due to van der Waals weak forces, dispersion bond, the dipole, hydrogen bond. These are called secondary bonds. Right? So in most materials, the atomic bonds are predominantly one type. However, in some materials, a combination of different bonds can form. Right? We have different type of metallic ionic bonds, primary bonds, and again different type of secondary bonds. Inside metals, you can find metallic bonds and others also covalent bonds. Then ceramics, you have ionic and covalent. Polymers, you can form hydrogen, and again you have covalent bonds, right? So we'll discuss what is those ionic and those things. Then primary bonds. Under primary bonds, we can discuss metallic bond. That is one of a primary bond. Metallic bond is one of a primary bond, and it occurs inside atom, right, in between atoms. The metallic bond occurs between atoms with only a few electrons in their outer s and p orbitals. Right, so these electrons are bound to the atom which much less strongly than those in the atoms in nonmetals. Right, here you can see some positives and negatives. You know, positives are nucleus and negatives are electrons. So inside a metal or a solid, we can see regular arrangement of nucleus, that is positives, and regular arrangement of electrons. Right, we call this a electron C. Right, so nucleus are in the electron C. Right, so we call delocalized electrons. This is a kind of a metallic bond. Right, here you have a electron C, and inside the electron C you can have a positive nucleus. So the metallic bonding is observed only among atoms in metallic elements, right? These are only in the metallic elements, metals. And the bond is formed due to electrostatic attraction between positive ions and electron clouds. So the electrons can move freely among atoms, right? So most of the time you can see metallic bonds inside the metals, right? The free electrons in metallic bond occur for high electrical and thermal conductivity. You know that the conductors, most of the conductors are metals because they have so many free electrons. So free electrons can move, right? That move is we call vibration only. Otherwise electrons can't move from one place to another. They are doing some of the vibration, right? So due to the vibration they can transfer energy. The transferring energy is what we call as the current, right? That is the electrical transfer. And again thermal transfer is same, right? Thermal, that is also energy. That heat can transfer through these electrons. That is also one of a conductive method, right? That is why metals are so many conductors. Then properties of metallic bond. Metals possess electrical and thermal conductivity because of free electrons which act as charge and heat carriers, right? So if they can't conduct, that means if they do not have any free electrons, we call insulators. So metallic bond is non-directional bond. So these words are something very specific for this kind of topics, right? Non-directional, because we do not find any direction, because if you get a cubical shape metal like iron, right? Cubic shape iron. Then if you try to put these sides, right, opposite sides to conduct electricity, that means you have 6 phases, right? So if you get left face and right face, then if you connect positive to the left and negative to the right, you can have a electrical current. Then again, if you get upper phase and lower phase, if you add positive to the upper and negative to the lower, then again you have a current flow. So likewise, it is not non-directional, right? We can't find any direction, but electrons can move. So due to high ductility and malleability, metals undergo large plastic deformation. So we'll discuss what is called plastic also in the phase diagram. The melting point of metal is slightly lower than the ionic crystals, right? Because that is something we call melting point. Right? Melting means solid becomes liquid. That temperature we call melting point. So in the metals, you have something slight lower than ionic crystals, right? Ionic crystals mean salt is one of a ionic crystal. Then ionic bond, that is about metallic bond, and again another primary bond is ionic bond. The ionic bond form between metal and a non-metal. Now here you can identify ionic bond can form inside metal and again a non-metal. But metallic bonds only inside metals. So normal atom is electrically neutral. However, if an atom loses electron, it becomes positive ion. We discussed that, right? If something if an electron move away from the atom, it becomes positive. Then if someone gets an extra electron, it becomes negative, as sodium and chloride, right? So sodium has one of electron in the last energy level. Then he can remove that electron. Then it becomes positive ion. So that removing electron can get into a chlorine atom. Then it becomes chlorine ion. It is negative, right? Then sodium is positive. Then chlorine is negative. Then you can have a connection in between positive and negative. It is called ionic bond. The metallic element gives up one or few electrons to the non-metallic element, producing two opposite charged ions. So the positive and negative ions have a neutral attraction for each other, producing a strong bonding force, and it is referred to as the ionic bond. Right? Sodium chloride is an example. Right? Previously, I already shown to you how sodium and chloride get together. So here you can see sodium 1s2, 2s2, 2p6, 3s1, because it is 11th one. So gives away one electron from sodium plus ion. Then chlorine, you have 1s2, 2s2, 2p6, 3s2, 3p5. Then it can take one electron and becomes chlorine minus ion. So thus there is a force of attraction between oppositely charged ions and form an ionic bond. Right? You have positive one and again you have negative one. Then there is a bond. It is called ionic bond. Right? Here you can see, right, this is one electron goes to chlorine and it now it becomes sodium plus, and this is chlorine minus. Right here, this electron removed and it goes to chlorine. Then it is chlorine minus and sodium plus after, right? Then properties of ionic solids. So general properties of ionic solids include moderate to high strength, then high hardness, brittleness, we'll discuss those, and high melting point, low electrical conductivity, and non-directional bond. Right? This is also one of a non-direction, because we can't find any direction to happen the bonding. Right? There are so many ways to happen it, so it is called non-directional. So here this electron, sodium, one electron goes to chlorine and becomes 288, right? That is the final form of chlorine, and it is Cl minus and the sodium plus. Then they have formed a bond. It is called ionic bond. And another primary bond called covalent bond. Covalent bond is resulting from sharing of outer electrons. Now they shared something. There is no an element to remove electron. There is no one element to take it. They try to share both electrons. That is called covalent. So that each atom has a complete outer electron shell. Covalent bonds are highly directional. So you have a direction, right? Because you know at the end of this energy level, you can have 2 electrons each, right? In the orbital, we discuss. We have clockwise electron and again anti-clockwise. So in that case, we can see how they are sharing those electrons. As example, HF, right? Fluorine. Fluorine 1s2, 2p5. So 2p5 means there is a space of 1 p orbital because there is a 7th element. And it has valence electron, so it can fill one from if someone removes electron. That means if sodium removes 1 electron, then fluorine can grab it and you can complete the 2p6. But here only hydrogen, because hydrogen can't remove this electron, so he is trying to get 1 electron from another one, right? So then they can form sharing those 2. So he can share this one in with the p orbit. Here s orbit and here p orbit. So both they can share the common electron. Again H2, right here you can see H only 1 electron. So they can share both 1 electron from each one. Right? That is called sharing. So this is a covalent bond. Bond means there are 2 atoms. So both 2 atoms getting a sharing bond. It is called covalent. And again Cl2, F2. Likewise Cl also you have again P5, right? Then you can get one from Cl, another one. They can form a sharing bond. It is called covalent bond. Right? So the reason that the 2 chlorine atoms stick together is that the shared pair of electrons here. Also you can see hydrogen is pairing one with the carbon. Then it is called CH4. It is attracted to the nucleus of both chlorine atoms. So covalent bond energies are generally high, indicating the formation of a strong bond, because this is very strong. So each one do not try to escape from the bonding because they are sharing something. So other one is not like to remove the other atom, right? Both are trying to get some kind of sharing forces. Then that is very strong bond. So however, many material with covalent bonds do not have a high strength and high melting temperature. So this is due to the weak secondary bond that are present between molecules. So I'll discuss what are secondary bonds. So here now we can see both atoms are getting into touch to form these primary bonds. Right? That is what primary bonds mean. So interatomic bonds are covalent bonds. Right? You know that energy is forming due to forming the bonds. Then intermolecular bonds are secondary bonds due to van der Waals forces. We'll discuss that also. Intermolecular and interatomic. So if somewhere is getting interatomic, that is primary. Intermolecular, it is secondary. The properties of covalent bonds. Covalent solid has a directional bond. We'll again see, because direction means only this one. This one, right? So we can't find this here. Right? That is what we call direction. Then high strength to hardness, high melting point, and again low electrical conductivity, because if you want to conduct electricity or any heat or something, you need extra free electrons. Right? But here they are sharing the electrons, so there is no any free electrons after forming these covalent bonds, right? So that is about the primary bonds. Then we'll move to secondary bonds. Secondary bonds are intermolecular. I will mention that, right? Because they are forming inside molecules. So they are relatively weak. They occur due to van der Waals weak forces. The dispersion bond, dipole bond and hydrogen bond are the secondary bonds. So in most material, the atomic bonds are predominantly one type. However, in some materials, a combination of different bonds are formed, right? We discussed metals, metallic and covalent, ceramics or ionic and covalent, polymers, we have secondary bonds and covalent. That is a mixture of bonds. So that one also we have to identify before doing some kind of modifications. So under secondary bonds, first one we call dispersion bond. So dispersion bond one result due to van der Waals forces. So van der Waals means that is kind of a temporary ionization. Right? What you know what is ionization mean? Ionization mean if someone gets slight positive here, this is the atom. So if the atom is something include with electron cloud, there is no any change of electron cloud, that is neutral. But sometime due